All right, so here's a potential extra credit question. Yes, we just need to know the basics of what's associated with this. We're not getting into it hardcore. However, it is nice to see what's going on here. Here is an actual proof. So if you're going to make the proof behind what this is, not just look at the graph, but do the actual math proof, then here's what this would look like. If we want to prove that the limit as x approaches 4 of 4x minus 15 is equal to 1, using the precise definition of a limit, right? The precise definition of a limit is the epsilon delta definition. So sometimes it is called that. All right. Just depends on who you're talking to, what book it is, all that kind of stuff. I am not going to have you do this for your test. You are not going to have homework problems over this. However, I think it's important for you to be able to look at this because I could potentially make it an extra credit problem on this test. All right? So heads up on that. The only time you're going to see this is right here in our notes. So it's good to be aware and take a look. All right, here's our solution. When you set up a proof, you have to say what it is that you're going for and build from there. So here, that's solution, SOLN, even though it doesn't look like it. Okay, we are going to find delta given that A is equal to 4 and L is equal to 1. So before we looked at our graph of our functions, right? And we found our delta based off of that. Now we have to get our epsilon. We are going to assume that epsilon is greater than 0. So if the absolute value here of f of x minus the limit is less than epsilon, then plug in what we know. The absolute value here of 4x minus 15 minus 1 is less than epsilon because that's f of x, plug that in, minus my limit, which we know to be 1. So we've got the absolute value of 4x minus 16 is less than epsilon. You could factor a 4 out. That's absolute values. Divide by 4, and I have x minus 4 is less than epsilon divided by 4. Now here's the deal. We want to figure out what this epsilon is, but you know when we had our definition, and I'm going to swing it back over here real quick, when we had this definition, right? This happened whenever this situation happened. Right? So my goal is to get this part set up. X minus A is less than delta. Look what we have right here. X minus A is less than delta. So this is the form. Let me put a little note here. This is in the form of X minus A, those are absolute values again, is less than delta. All right? So this is part of the proof. We've set this part up. Therefore, let me get this out of there so we have actually room. We see the relationship between epsilon and delta. Is that delta is equal to epsilon divided by 4. So we see this relationship. This is setting this up. We're getting this proof. We're setting this up. Now we know information about epsilon and delta. So here's our proof. We're going to let epsilon be greater than 0 and assume that 0 is less than x minus 4, which is less than delta. And remember, something happens whenever that relationship is, okay, where, because we already figured this out, delta is equal to epsilon divided by 4. So if that's the case, 0 is less than the absolute value of x minus 4, which is less than epsilon divided by 4. We want to show that the absolute value here of 4x minus 15 minus 1, because that's f of x minus L, is less than epsilon for all x, such that 0 is less than the absolute value of x minus 4, which is less than delta, right? So this is back to our definition again. F of x minus L is less than epsilon whenever 0 is less than the absolute value of x minus a, which is less than delta. Then you make it happen, Captain. So we know that the absolute value of 4x minus 15 minus 1 actually equals the absolute value of 4x minus 16, which equals, when I factor out a 4, the absolute value of x minus 4. Assuming that the absolute value of x minus 4 is less than epsilon divided by 4, right? Because that was where we assumed up here. Then this, so we're taking it down from here. So then this equals 4, if I multiply both sides by 4, of x minus 4, which is less than epsilon. All right? Because I have, wait. Yes. We're good. Okay, so I have 4 here times 4 times x minus 4, because it came from right here. That's where we said, right? Here is now less than 4 times, that's where I forgot my 4. My bad. So this is now equal to epsilon divided by 4 times 4. Because if I multiply this side by a 4 and this side by a 4 in order to get it back to where we have it. All right, and I have that epsilon divided by 4. All right, good. Now we have shown that those are the same. Because I can look at this and say that 4 divided by 4, we now have it back up here where we have epsilon divided by 4, which is what we had. 4 times that gives me that epsilon divided by 4. Good. Now I just have this epsilon right here by itself. So here's our final statement. We have shown, well, I need to write, sorry, I should write equals epsilon, just so that there's no question. I canceled out those, but that way there's no question. Okay. We have shown that the absolute value of f of x minus L equals the absolute value of 4x minus 15 minus 1, which is less than epsilon, when 0 is less than the absolute value of x minus 4, which is less than delta, provided, this is the kicker and this is what we learned, provided that 0 is less than delta, which is less than epsilon divided by 4, right? Therefore, the limit as x approaches 4 of 4x minus 15 equals 1. Okay, I'm going to do a brief talk through on this. Please know the reason why we don't do a whole lot of proofs in this class is because this is how you set up a proof and how you work it out. I am more concerned that you can pull this off rather than write the big long proof associated with it. If you get into some upper level math classes, if that's where you're going with your degree, you'll be doing a lot more proofs, all right? Proving why these things happen. For our intents and purposes, this is why it's extra credit. Okay, so here we have this setup. Given this setup with the information we have, we can determine the relationship between epsilon and delta right now. All right. Once you set that relationship, then you use it in the proof. I'm going to scoot this up. Now, if I use it in the proof, we are going to assume this to be the case because that was our definition, and we're using this relationship that we have here. Okay, so if this is happening because delta is equal to x minus 4, then we could say, how is this relationship going? How can we make this look like this and be the same deal? So I work all of this out and I'm saying, okay, we have this assumption based on what we've been given. We have assumed this is happening, so this is happening, right? When in proofs you have this assumption, then you say, okay, if I know that I can take this x minus 4 and multiply 4 by both sides, multiply this side by a 4 and multiply this side by a 4, those cancel and I'm just left with epsilon, right? That's how we're looking at this. So if both of those cancel here, and I know I have this set up and my epsilon and my delta are the same, when you multiply both sides by 4 here, then you have this as your epsilon, which means this relationship is equivalent to this one. So I'm showing that whenever I take the relationship between delta and epsilon and we work it all the way out, we end up with my f of x minus L is less than epsilon because we are left with just epsilon here. And this is f of x minus L. All right. And so that's what this means. We have shown that this is less than epsilon because this statement is equivalent to this one, which is less than epsilon. When you have the relationship here with delta, knowing that those two are equivalent, provided this relationship. And therefore, this limit has just been proven. All right? It's a whole lot of work to do what we've been doing this whole time where we say, oh, because of all of this work and we know the relationships between delta and epsilon, we say, what do? You plug it in. And guess what you do? Oops, right here. You plug this in and then you come up with your limit, your answer. So 4 times 4 is 16 minus 15 is 1. We're going to use the practical of this, but it is nice to know the proof behind it, right? If we want to get real mathy on it. But I don't want you to stress over this stuff. I'm not going to test on this potential extra credit, but that's just extra credit. All right, cool. You've got this. Good.